Well, hey there, kitties. This was not the factoring assessment or pre-assessment that I did in class, but this is going to help you with some factoring. So I just want you to get some practice with it. I'm going to formally teach this more in class when we're in class, but I wanted to give you another opportunity to try some of this on your own just to kind of play with it. And then I think when we get in class, I'll do some more formal work with it and see if I can help you out, figure out how to do more of this. But right now, we're just going to try these. Now, what you're doing for me is you're going to try this, but if you look, the factoring homework looks very similar to many of these. So we're going to do a couple of similar kinds, and then you could go try these on your own and do them for homework, okay? So let me get that kind of zoomed in there for you. There's our first problem. What? Oh, yeah. Before I start math, I drink my Dunkin' Donuts iced coffee. It's delicious and makes my brain work better when it's working on math. Seriously, Dunkin' Donuts? I'm your man. I am your man. I could just, nail those commercials. Yeah, get the next generation of kids hooked on coffee. Wait, can't do that. That's not a good idea. Don't drink coffee. It stunts your growth. Wait, drink coffee. It's delicious. I don't even know what I'm saying anymore. Let's just do math. All right, here we go, kids. Factoring. This is called a trinomial. Tri means three, and then nomial means terms. Sort of something like that. Nomialistic. Monomial is one term, so trinomial is three terms. We want to convert that to the product, meaning multiplication, of two binomials. So, first things first, we're going to put an x here and an x here. Now, why when we do that? Well, when we double distribute, x times x is x squared, and that's what we want. So that's done. Now, the next thing we're going to look at is this. Is there a bigger size? Can I just make this smaller? All right. I want to make, the next thing we're going to look at is this. And this, it's really a positive 24. So I'm not going to get into too much, but in order to multiply to a positive, you need two positives or two negatives. Okay? So I need a way to multiply to positive 24, but when I And because this is a plus sign, I want them to add up to 10. So I can do 1 and 24. I can do 2 and 12. Those don't add up. 3 and 8. Or 4 and 6. And I need the pair that's going to add, because this is positive, I want the pair that's going to add up to 10. So plus 4 and plus 6. Now, you'll notice that this next problem is almost exactly the same. Almost exactly the same. And the only difference is this is a plus 10x and this is a minus 10x. So if I was to factor this one, x and x, I need two numbers that multiply to positive 24. But when I add them up, they get negative 10. Well, it's still 4 and 6. But instead of being positive 4 and positive 6, it's now negative 4 and negative 6. Because negative 4 and positive 6, when you add those two things together, you get negative 10. And a negative 4 times a positive 4, or excuse me, a negative 4 times a negative 6 is positive 24. All right, let's look at the next problem. All right, I need two numbers that when I multiply them, they give me positive 18. But because this is a positive, they have to add to the middle. So I can do 1 and 18. They don't add up to 9. I can do 2 and 9. They don't add up to 9. I can do 3 and 6. Oh, those add up to 9. 3 and 6. Now, I'm going to teach you some things, but whenever this is positive, the two signs have to be the same. They either both have to be negative or both have to be positive, and it's always whatever this is. So in this case, I want positive 3 and positive 6. All right, this is so. X and X. Notice they're positive. It's positive 32. So that means the signs are going to be the same, and they're both going to be negative. That's how that works. So now I got to come up with all the ways to multiply it 132 or to positive 32. But because this is a plus, they have to add up to 12. So I'll stop as soon as I get two numbers that add up to 12. So 1 and 32. They multiply to 32, but they do not add up to 12. 2 and 16. They add up to 18. 3 doesn't go in. 4 and 8. Oh, look. Those add up to 12. So 4 and 8. Oops, terrible boxing. All right. So positive 20. Oh, I might have messed this one up. Oh, no, I didn't. I did rock like a rock star. So I need two numbers that multiply to 20, but they add to negative 12. Oh, because this is positive, I need two negatives. And I need two negatives because when I'm done, I got to have it adding up to a negative. All right, so 1 and 20. Those then add up to 12. 2 and 10. Those don't. Oh, those add up to 12. Minus 2. Minus 10. All right, let's move on to the other side. Other side I think is going to be a little bit more challenging. So when we get over here, you'll notice on this side, all of our numbers at the end now are negatives, which means we have to subtract two numbers to get 7. So, coming up with all the ways to multiply to 30, but when I subtract them, they give me 7. 1 and 30. When I subtract those, I get 29. 2 and 15. When I subtract those, I get 13. 3 and 10. When I subtract those, I get 7 when I subtract those. There's another one, 5 and 6, but I only get 1 when I subtract those. So when I subtract 10 minus 3, I get 7. Now, I need you to understand that you're subtracting because this is a minus. So we're going to subtract two numbers together. That they give you 7, but when you multiply them together, they give you 30. It's actually negative 30. So I know we're going to have 3 and 10. Now, I want these to add up to a positive 7. So that means my larger one needs to be positive and my smaller one needs to be negative. Think about it. Positive 10 minus 3 is positive 7. But if I had negative 10 and a positive 3, that would give me negative 7. I want the positive 7. Okay? Take a quick break. Okay, so you'll notice, just like on problems 1 and 2, these problems are very similar. The only difference is now I want a negative 7 instead of a positive 7. So now I'm going to do x and x, 3 and 10. But now I want to use this one because those add up to negative 7. So now I want to use negative 10 and positive 3 because that will give me the negative 7. All right. Now, 18. Again, we need to subtract to get positive 7. So I can do 1 and 18 because 1 times 18 is, in fact, 18. But when I subtract them, I get 17. 2 and 9. When I multiply them, I get 18. But when I subtract them, I get 7. Oh. Now, remember, the only other way is 3 and 6. But when I subtract those, I get 3. I want the ones when I subtract, I get 7. So you have to decide, do you want negative 2 and positive 9? Or do you want positive 2 and negative 9? When I put these together, I get 7. I know this is behind my head. And when I put these together, I get negative 7. Well, I want positive 7. So I want negative 2 and positive 9. I think we got 2 left, kiddos. So, 2 sets of parentheses, x and x. Because this is a minus, I want them to subtract to give me 2. It's actually negative 2. So 1 and 35, those don't subtract to give you 2. And then 5 and 7. Oh, when I subtract those, they give me 2. So do I want negative 5 and positive 7, or do I want positive 5 and negative 7? Well, these add up to 2. These add up to negative 2. I want negative 2. So positive 5 and negative 7. And I think this is our last problem. Sweet. X and X. So I need two numbers that when I add them together, when I subtract them, they give me negative 1. Yeah, remember there's a 1 there. So it's when I subtract 1 and 12, those multiply to give you 12, but they subtract to give you 11. 2 and 6, when I subtract those, I get 4. 3 and 4, when I subtract those, I get 1. So do I want positive 3 and negative 4, because that equals negative 1, or do I want negative 3 and positive 4, because that would equal positive 1? I want negative 1. So I want these, positive 3 and negative 4. All right, so that's it for that. That's a real quick, short video. Your job is to try to do and learn what I taught you. You can go back, you can rewind the video, and try to do the ones that are on the homework question. All right, kids, catch you on the flip side. Goodbye. When I leave math. No, I'm just kidding. No more Dunkin' Donuts. Too much.